Hello guys, welcome back. You are watching Engineering Civil Academy. Today we are starting with our new topic, that is fluid mechanics. So in fluid mechanics, basically we are dealing with fluid statics and fluid kinematics and fluid dynamics. So as far as fluid kinematics is concerned, it is basically study of motion of fluid particles without considering the basic cause of motion. ठीक है, that is our fluid kinematics. But in dynamics, that is we are considering the basic cause of motion. ठीक है, in this dynamics, that is the study of motion of fluid particles by considering the basic cause of motion. ठीक है, that is our fluid dynamics. So what is the basic cause of motion? This is the point. So the basic cause of motion is force. So in fluid kinematics, we didn't consider force. In fluid kinematics, we didn't consider force, but in dynamics, we consider force. So this is the main difference. So coming on to the next part, that is basically fluid is having a one very important property of continuous deformation under the action of shear force or tangential force. So fluid has a special property of continuous deformation under the action of shear or tangential force. That means fluids are having very low or negligible shear strength. That means they are having negligible shear strength. Okay? But unlike in solids you cannot move them easily because they are having a very high shear strength, due to which they can't be moved easily. They can't deform under the action of shear force or tangential force. Can deform, elastic bodies are deformed, but rigid body didn't deformed very easily. So in fluids we are having a property of continuous deformation under the action of shear or tangential force, right? So which is not happens in solids. So एक रीजन इसका ये भी है, ड्यू टू वीक इंटरपार्टिकल फोर्स, इनकी जो इंटरपार्टिकल फोर्स रहती है फ्लूइड्स में बहुत कम रहती है, जिसकी वजह से ये इजीली डिफॉर्मेबल है फ्लूइड्स. बट सॉलिड्स आर हैविंग अ वेरी स्ट्रॉन्ग इंटरपार्टिकल फोर्सेस, जिसकी वजह से वो इजीली डिफॉर्म नहीं होते. ठीक है, तो इट इज नॉट हैपन इन सॉलिड बिकॉज ऑफ हाई इंटरपार्टिकल बॉन्डिंग as compared to fluids. बेसिकली फ्लूइड्स, हम अगर स्टेट्स ऑफ मैटर की बात करें, जनरली वी आर डीलिंग विद सॉलिड्स, लिक्विड्स एंड गैसेस। ठीक है, तो these two liquids and gases are put in different category called as fluids. So we are basically discussing the properties of fluids. Now next topic is, that is fluid as continuum. What does it mean? It means as compared to the dimensions of the system, interparticle distance is taken as negligible. Okay, so what does it mean? For example, we're taking one system, sorry, so this is a system which contains fluids, and in this system the fluid particles are assumed to take a spherical or close to the spherical shape. These are the particles. Basically it's a fluid, any kind of fluid can be there, so it is continuous, right? What I am trying to show, that if you see the interparticle distance between any two particles, see these, so these distance is very small, very small interparticle distance as compared to what, अगर आप डायमेंशन ऑफ सिस्टम की बात करोगे, ये हमारी लेंथ है, ये 3D में, ये 2D में बनाया मैंने, वैसे 3D में है, ये हाइट है, और पीछे की तरफ जो होगी विड्थ होगी। तो आई एम ट्राइंग टू शो दैट, सी नेम्ड इट एज डेल्टा, द स्पेसिंग इज डेल्टा, so the length, width and height is greater than delta, due to which due to which hence it is assumed that what, delta is negligible, or what we are trying to say, that the fluids are taken as a continuous mass. ठीक है, so that is the concept of fluid as a continuum. I hope you understand the concept. Now coming on to the next part, that is properties of fluids. Starting with the first property, that is density, right? So this is our first property, density. What is density? It is very common term. It is defined as mass per unit volume. So Density of water is taken as for calculation purpose is 1000 kg per meter cube. That of air is taken as 1.21 kg per meter cube. So it is to be remembered. This is very common. Second is specific weight. So these are very common terms and has been asked in your MCQ previously. So what is specific weight? It is the weight per unit volume. Density basically written as rho. So it is to be remembered. It can be represented as rho. Specific weight, we will write it as SW. So SW is weight per unit volume. So weight is mg per unit volume. So this is your specific weight. Unit weight भी आप कह सकते हैं. Third part is your specific volume. It is also very important and has been asked as a definition, that is what is specific volume in your PYQs. So specific volume basically it is the volume per unit mass, or you can say it is the inverse of density, or it's a inverse of density. So I can write SV, that is specific volume, is 1 upon rho. So it is to be remembered, it is important. Now next part is relative. Before that we will study about specific gravity. Specific gravity, it is the ratio of density of one fluid to the density of standard fluid. ठीक है, अगर आप इसको ऐसे भी लिख सकते हैं, स्पेसिफिक ग्रेविटी इज डेंसिटी ऑफ रो में लिख रहा हूँ मैं, डेंसिटी ऑफ एनी गिवन फ्लूइड, रॉ फ्लूइड लिख लेता हूँ. ठीक है, ये हमारा गिवन रहता है, इसकी निकालनी होती है. और नीचे लिखते हैं हम रॉ स्टैंडर्ड फ्लूइड, रॉ फ्लूइड स्टैंडर्ड. तो आप देखेंगे डेफिनेशन में हम जो स्पेसिफिक ग्रेविटी निकालते हैं वो बेसिकली सेम नेचर के फ्लूइड में निकालते हैं. जैसे दोनों फ्लूइड है तो दोनों लिक्विड ही होंगे या दोनों गैस ही होंगे. ठीक है, तो सेम नेचर के ही होने चाहिए, तभी हम स्पेसिफिक ग्रेविटी निकाल सकते हैं. ठीक है, फॉर एग्जांपल अगर आप वाटर की बात करें, हम स्टैंडर्ड फ्लूइड जो है वाटर लेके चलते हैं. स्टैंडर्ड फ्लूइड इन केस ऑफ लिक्विड इज वाटर. तो वाटर की डेंसिटी हमें पता है, हम कितनी लेके चलते हैं. रो ऑफ वाटर, रो डब्ल्यू इज 1000 kg पर मीटर क्यूब. अगर आप स्पेसिफिक ग्रेविटी ऑफ वाटर की निकालते हो तो कितनी आएगी, 1. कैसे आएगी ये देखिए, स्पेसिफिक ग्रेविटी ऑफ वाटर इज, क्योंकि हमने वाटर ही ले रखा है तो हमारा गिवन फ्लूइड जो ऊपर आएगा वो वाटर ही आएगा. तो ऊपर कितना आएगा, 1000 kg पर मीटर क्यूब. और वाटर में हमारा स्टैंडर्ड फ्लूइड क्या रहता है, वो भी वाटर लेता है, वो भी क्या रहेगा, 1000 kg पर मीटर क्यूब. तो दोनों कट के क्या बन जाएंगे, 1 आ जाएगा. तो स्पेसिफिक ग्रेविटी ऑफ वाटर इज टेकन एज 1. It is important and it is to be remembered. Okay. In we are taking air as a standard fluid, or it has been your hydrogen and methane has also been taken as a standard fluid in case of gases. Okay. So next part is, this is your specific gravity, and next is relative density. It is your fifth one, is relative density. देखो, रिलेटिव डेंसिटी और स्पेसिफिक ग्रेविटी में क्या फर्क है? रिलेटिव डेंसिटी में हम क्या लेते हैं, इट इज द रेशियो ऑफ डेंसिटी ऑफ वन सब्सटेंस टू द डेंसिटी ऑफ अनदर सब्सटेंस। तो दोनों सब्सटेंस डिफरेंट हो सकते हैं, सेम नेचर के पार्टिकल नहीं रहते हैं रिलेटिव डेंसिटी में। सो वी विल राइट इट एज इट इज द रेशियो ऑफ डेंसिटी ऑफ वन सब्सटेंस टू द डेंसिटी ऑफ another substance, राइट। में जो फ्लूइड्स लेते हैं वो अलग अलग भी हो सकते हैं। तो डेंसिटी ऊपर हम लेते हैं ऑफ रो ऑफ एनी गिवन सब्सटेंस टू द रो ऑफ एनी अदर सब्सटेंस। इसमें स्टैंडर्ड कोई भी नहीं रहता है, कुछ किसी के भी रिलेटिवली हम डेंसिटी कैलकुलेट कर सकते हैं, तभी हम इसको हमने नाम दिए दैट इज रिलेटिव डेंसिटी। चाहे आप अदर सब्सटेंस में वाटर ले लो, मर्करी ले लो, और एनी अदर फ्लूइड ले लो, ठीक है। That is why it is termed as relative density. So this is all about the property of the fluids. In next video, we will discuss about the viscosity, surface tension, and compressibility of the fluids. I hope if you like this video, and please do subscribe and like my channel, and it will help me and motivate me to bring more and more videos for your examination purpose. Thank you.